What if Earth isn't the best planet for life, and we've already discovered a world that might be better? A planet orbiting a distant star in one of the most unusual systems ever found. This is TRAPPIST-1e, a rocky world 40 light-years away in the constellation Aquarius. It belongs to one of the most compact planetary systems ever discovered, where multiple worlds orbit their star closer than Mercury is to our Sun. At the center of it all is a small, dim red dwarf star, TRAPPIST-1. Cooler than our Sun, fainter, but far more unpredictable. And around it, 7 Earth-sized planets, packed so tightly that from the surface of one, the others could appear larger than our Moon. Imagine looking up and seeing entire worlds hanging in the sky. And right in the middle of this system is TRAPPIST-1e, a planet located in the habitable zone, where temperatures could allow liquid water to exist. At first glance, it sounds almost perfect. Its size is nearly identical to Earth's. Its gravity is about 93% of ours, and it receives just enough energy to avoid freezing solid. It might seem like a second Earth. But there's a problem. Because being in the habitable zone doesn't make a planet habitable. In this system, one thing controls everything. Not the planet, but the star. TRAPPIST-1 is an M-type red dwarf. Unlike our Sun, red dwarfs are far more active in their early stages, releasing frequent, powerful stellar flares and intense radiation. Over time, that radiation can strip away planetary atmospheres long before life ever has a chance to begin. So even if TRAPPIST-1e once had an atmosphere, it may not have kept it. And without an atmosphere, everything changes. No stable climate, no protection from radiation, no liquid water on the surface. A planet that looks like Earth from a distance could, in reality, be completely lifeless. But there's another possibility. If TRAPPIST-1e has a strong magnetic field, or a dense enough atmosphere, it might have survived. And that changes everything. Because if life exists there, it evolved under conditions unlike anything on Earth. A dim red star, fixed in the sky. A world likely tidally locked, one side in permanent daylight, the other in endless night. So where could life survive? Not across the whole planet, but in a narrow band between extremes. A twilight zone where temperatures remain stable. Or even beneath the surface, shielded from radiation. Life there wouldn't just be different. It would redefine what habitable really means. Before we continue our journey into this mysterious world, consider giving it a like and subscribing so you don't miss what we uncover next. So, how do we actually figure this out? We don't travel there, we don't see it directly. We use something far more powerful: light itself. This is where the James Webb Space Telescope comes in. For the first time in history, we have an instrument powerful enough to study the atmospheres of Earth-sized planets around distant stars. And TRAPPIST-1e is one of its most important targets. And that is where things get really interesting. Because when the planet passes in front of its star, a small fraction of starlight passes through its atmosphere. And that light carries information. Different gases absorb specific wavelengths, leaving behind patterns like fingerprints in light. From those patterns, scientists can detect molecules such as carbon dioxide, methane, and water vapor. So what have we found? The James Webb Space Telescope has already observed multiple transits of TRAPPIST-1e, and the results are telling us something important. It has ruled out a thick, hydrogen-rich atmosphere, meaning this is not a mini Neptune-like world, which is encouraging. But the most important question remains unanswered. Does TRAPPIST-1e have an atmosphere at all? Right now, we don't know. And once again, the problem is the star. TRAPPIST-1 is highly active, covered in star spots, constantly flaring. Its brightness changes over time. All of this contaminates the signal we're trying to detect. In other words, the data is there, but buried in stellar noise. So scientists do something remarkable. They don't rely on a single observation. They collect data from many transits, stacking them over time to slowly extract a clearer signal. It's slow, demanding, and incredibly precise. Because this isn't just a limitation of our technology, it's the reality of trying to detect life across light years. So for now, TRAPPIST-1e remains a mystery. It could have a thin, Earth-like atmosphere, or it could be completely airless. We simply don't know yet. But that uncertainty is exactly what makes this planet so important. Because for the first time in history, we are not just discovering new worlds, we are beginning to study them. And if a planet like TRAPPIST-1e exists this close, in cosmic terms, then how many more are out there? Worlds that aren't just like Earth, but possibly better. So the question is no longer just whether life exists beyond Earth. It's this. What if Earth isn't the best planet for life, but just one version of it? And somewhere out there, worlds like TRAPPIST-1e are not the exception, but the beginning. If TRAPPIST-1e made you rethink what a habitable world could be, then there's a lot more waiting to be discovered. Consider leaving a like and subscribing. I'll see you in the next one.